Hello, and I want to welcome you to a discussion on polynomial functions and their graphs. So let's get started. Okay, so the degree of a polynomial is the coefficient of the variable to the largest power. So it's the leading coefficient, or excuse me, that's the leading coefficient. For the degree, it's the highest exponent that exists. So for number one, when we're asking if it's a polynomial function, and if it is, to state its degree, and if it's not, to tell why it's not. So number one, f of x equals negative 3x to the 7th power. This is a polynomial function. And it is a polynomial function because it has the power of 7th and a negative 3. It just fits the credentials. And it has a degree of the highest power, which is 7. With number 2, we have f of x equals 9 over x minus 8. Now what happens here is that fraction of x would give you an x to the negative 1 power. So that is not polynomial function because it would give you a negative exponent. Okay, number 3, f of x equals x squared plus 3x plus 4. This is actually what we were just discussing in the previous video of a quadratic function. So this is a polynomial function. And every quadratic has a degree of 2. So sorry about this. And it's the highest exponent, which is 2. Okay, with number 4, f of x equals negative 2x to the 5th times the quantity x minus 3 all squared with the quantity of x plus 1. And you can think that is a power of 1. This is in fact a polynomial function. And to get the degree, add the power of 5, 2, and 1. So 5 plus 2 plus 1 gives you the degree of 8. Okay, looking at smoothly continuous graphs and behavior of polynomial functions. Working with polynomial functions, you'll want to notice that the coefficient, that the end behavior of a graph of function to the far left or far right is called its end behavior. The sign of the leading coefficient a uses of n, and the degree n of the polynomial function reveals its end behavior. So here are the notes on coefficient, the leading coefficient test. So let's use this test with number 1. The degree of this, as you can see, is the highest one that appears, which is degree of 7. And when you have an odd degree, it means opposite in behavior. Opposite in behavior. And the leading coefficient is positive. Is positive. So the far points are up, falls to the left, and rises to the right. So the graph will have this for its end behavior. For number 2, we have f(x) equals negative x to the 4th plus 6x cubed plus 2. So as you can see, the degree is going to be 4, which is even, meaning same end behavior. And the leading coefficient is negative. So what does this mean? This tells us that we're going to fall to the left and we're going to fall to the right. Looking at the zeros of polynomial functions. If f is a polynomial function, then the values of x for which f of x is equal to 0 is called the zeros of x. These values of x are the roots of the solution of the polynomial equation f of x equals 0. So we have this equation f of x equals x squared times the quantity x plus 1 squared times the quantity x minus 3. So the factor of x occurs, or this x squared occurs 2 times. The factor of x plus 1, that power is 2, so it occurs 2 times. And x minus 3 is a factor. It just has a power of 1 or just itself, so it occurs 1 time. So we can use this information to work with multiplicity and x-intercepts. So multiplicity, if r is a 0 of even multiplicity and the graph touches the x-axis and turns around at r. If r is a 0 of odd multiplicity and the graph crosses the x-axis at r. So for number 1, f of x equals 4 times the quantity f of 4 times the quantity x plus 4 times the quantity x minus 5 times 1. So let's break each piece down. We have 4 equals 0, x plus 4 equals 0, and x minus 5 equals 0. Now this first case, 4 equals 0, is not true. We can't work with that. But for this, we can solve for the variable x plus 4, so that's minus 4 on both sides. You have x equals negative 4. So that's one intercept. But what happens there, it has a multiplicity of 1. Because it occurs once. And that means that it crosses the graph. Okay, and then for x minus 5 equals 0, let's add 5 on both sides. So I have x equals a positive 5. And for this, the multiplicity occurs to that power of 2. So that means the graph touches and turns around here. Okay, let's look at our second example. F of x equals 7 times quantity x plus 3 times quantity x minus 3 cubed. So, if we take a look at this, let's set all of our terms on the right side equal to 0. So 7 equals 0, x plus 3 equals 0, equals 0, and x minus 10 equals 0. Let's clean this up real quick. So this 7 equals 0 can't do anything with that. But x plus 3 equals 0, let's solve for the variable by subtracting 3 on both sides. So we have x equals negative 3. Now for the x plus 3 term, it has a power of 1, so it has a multiplicity of 1. And what does that mean for us? It means the graph crosses. It crosses the graph here. Now for x minus 10 equals 0, let's add 10 to both sides. So at x equals a positive 10, let's look at the multiplicity that occurs at this segment. X minus 10 is at a multiplicity of 3. And that is an odd multiplicity, so that means the cross is graphed at this part of the line. Let me just refer back to my time. And let's pause here and we will pick up with part 2 with looking